we're going to go ahead and shift gears to our second talk, who is coming from Domenico Cipriani in Italy, and he's from the Pharo Association. And the this talk is about Fausto, which is for prototyping DSP. And I'll just read his abstract very quickly to help give you an idea of what this talk is about. Learn how Phausto, a Pharo-based library and API, makes DSP programming accessible through Pharo's pure object-oriented model, minimal syntax, dynamic live environment. By harnessing the power of an embedded Faust compiler, Phausto provides full access to Faust's extensive libraries and exporters, enabling the rapid development of audio tools. We'll focus on its C major exporter, demonstrating how to create a plugin and use it within a DAW using the C major wrapper plugin. Designed for educational purposes, Phausto empowers sound artists, producers, and beginners, making advanced synthesizers and effects design quick and with that being said, I'm going to pass the mic over to Domenico. Take it away.
Hey, hi, Josh. Thanks a lot for having me here. And I've been learning a lot of stuff through the Audio Programmer channel, so I'm very happy to be here. Also, we have the book here. I learned a lot of stuff. So it's a pleasure to be here and to show the Phausto and all this framework to our follower on the channel. I want to thank also the Pharo Association for sponsoring my work. And then I want to thank all the ref team in Lille for helping me with Pharo and Phausto, and the Faust team for helping me in the stuff, and also Cesar Ferrari at C Major for making this really happen, because it was his final touch, as we will see, for having this C Major export. Okay. First of all, I would like to introduce a little bit myself and how I arrived to conceive Phausto, and I will discuss a little bit the technology used and their history. Okay, so I've been producing music, DJing, and performing live for almost 20 years, especially with machine, so with hardware and with vinyl. I got a degree in electronic music production at SAE in Barcelona like 20 years ago, and then I studied linguistics at the university. So I'm not a programmer. I mean, I'm not studying computer science at the university, but I learned by myself. And let's go with the slides. So, okay. So, as an introduction, I would say language as C++, Faust, and also C major, they are extremely powerful, but they are also very intimidating for beginners. And while Faust and C major are simpler, but still they are complex for people with little computer literacy, it could be musician or producer or sound artist. Okay, using Phausto together with C major bridges this gap and make it much simpler and much faster. What is Faust? As you were telling before starting my introduction, Faust is a multi-platform library and API for Pharo that is for writing DSP. It works on Linux, on Windows, on Mac OS X. It's quite lightweight. All the library is less than 10 megabytes. Phausto was developed with three main goals. It was to allow sound artists and musicians to program synthesizers easily with Smalltalk, with Pharo, and also to teach DSP programming to very beginners, and then to offer a platform for prototyping and use this DSP thanks to the C major and also with the C++ exporter. Then, of course, it was also to enrich the Pharo environment with sound, but today we are going to focus on point two, so writing this DSP code and plugins. I began programming in 2017, so not so many years ago, thanks to Christian Vogel and Symbolic sound Kyma. We will see in a while what is Kyma. Then I've been developing Koipu in Pharo for programming music on the fly. in 2020, and this was my first experience with Pharo. Also in 2020, I started to develop audio plugins with a company called Soft Computing that we founded with my friend DJ House of Unknown to the Unknown, and with using Juice, it was made possible for me to make the plugins that we did. And since April 2, 2024, I'm sponsored by the Pharo Association for my work with Phausto. A few stuff about Symbolic Sound Kyma. So Symbolic Sound Kyma is made by Carla Scaletti and Kurt Ebel at Urbana-Champaign. It is a IDE and computer language that is made for audio, for sound design and sound performance. The small talk code inside Kyma has to be compiled on an external DSP. The first one was called Capybara, then we have the Pacarana, and then we have the Pacamara Restrator now. For somebody, it's called the Holy Grail of sound design, as it is extremely powerful. It is also extremely creative, and as it is in Smalltalk, it is very easy to learn. So Smalltalk was the first language that I learned with the book on Kyma, and I got in love with Smalltalk. And Smalltalk is so easy because when it was conceived in the 70s by a group of researchers, including Alan Kane, Dan Ingalls, and Dalen Goldberg, and more, it was a language that was conceived for teaching programming to children. And this concept of Smalltalk introduced like graphical user interface, model view controller, and a live programming environment that we also have in Pharo. Okay, so Pharo also is a pure object-oriented language that comes with a platform-independent IDE, so it works on Windows, Mac, and Linux, again, with very small requirements, and there is a lot of retrocompatibility, so it goes on ARM, it goes on Intel, it goes on very different OS. Pharo comes from a fork of Squeak created by Stefan Ducasse and Marcus Denker, and it was thought as going beyond the original of ideas of Smalltalk, so to make a real world language. And now it's developed by an international community and maintained by the Pharo Consortium. It has a non-viral MIT license, so it can be used everywhere. And it comes with integrated Git support and with an integrated framework for S-unit tests. So with a lot of stuff, we will not have, I think, time to see a lot of about Pharo, but there are a lot of tutorials, a lot of videos online to learn about Pharo, a lot of books. I will give you a quick look of how Pharo looks like. This is Pharo 12. Okay, so on the top left, we have Iceberg, that is for committing and pushing your code, so for versioning. Then we have the playground, when you can write your code and evaluate your code in real time. Then on the right, we have the inspector, that is to inspect objects and to debug codes in real time. And then we have the class browser, where we have our classes and where we define our methods. So let's say in the playground, you sketch your code, but then your code goes inside actually packages and classes for reuse, okay? The syntax of Pharo fit a postcard, okay? It's very concise, it's very easy to learn. We have 6 rules, like as you can see there. Everything is an object, every class has a superclass, everything happens by sending messages, method lookup follows inheritance chain, and classes are objects too, and they follow the same rules. And then there are the precedence rules are very easy also. So ordinary message first, binary messages then, and then keyword messages. When there are multiple messages with the same precedence, they go from left to right. So for example, 3 plus 5 times 4 would be like 32. And for those who don't know Faust is a purely functional programming language. So it's like on the other side of the programming language spectrum, respect of Pharo. but is considered the state of the art in the research and development of DSP algorithms. There is a lot of work in filters, physical model, reverbs, effect analyzers. So with Faust, it comes a very extensive standard library. I really love the sound of Faust, especially for this quality. And Faust then compiles to C++. You can use it on an online editor, or you can use it for command line. But what was also very good about Faust is that its architecture and its CBox API was enabled like to embed it on Pharo quite easily, let's say. Here is a brief look at what comes with Faust. A lot of things, a lot of oscillators, low frequency oscillator, impulse train, waveguide, resonator, many filter, a different collection of linear and exponential envelope generators, tons of effects, a lot of first-class reverbs, physical modeling, instruments, and low-level stuff, analysis tool, dynamic processor. So we have everything. And then why C major? Well, I like a lot of C major, and it was easy to export the DSP code from Faust, so from Phausto to C major. And it is really easy to use the C major patch that is created, just loading this patch in the C major plugin that is given by the C major team. So as we will see later, it's really easy to use the C major patch inside the VST wrapper, and I think this is something that can really speed up the development of plugins and also the use of plugin, especially if you think for like artists and producer. If you like, for example, you want to have your own synthesizer, something maybe not so complex, but you have ideas for doing that, you can just plug what you got in Faust and export it to C major. So there are many resources to learn Pharo. There is a massive online open course that is around 7 weeks at slow speed, I would say. And then there is also an advanced course with 10 modules to learn proper object-oriented programming design, so like design pattern, and everything you need to write proper code. Also, you can use Pharo is reflective, and you can inspect everything, so you can learn from inside Pharo because you can look and read every method and every class. And then there are also a lot of free books. To install Phausto, you have first to download the Pharo Lancer. That is a tool that is used to launch Pharo images. Then there is this GitHub page where you have to download this libraries bundle. That is a folder that contains the compiled dynamic engine, the libfaust, and in case for Windows and for Linux also port audio, while for Mac we are using core audio for the sound. And then we just have to copy this command on the playground. That is where we play with our code in Pharo, and it will load everything we need. How we learn Fausto then? Well, we can open a playground and evaluate master loop Go, and it will open a series of tutorials. Now we have 7 tutorials covering the very basics, but we are working on more. And also, we kept the semantics of Fausto very close with Faust, and we choose to have the same name for the parameters as in Faust. So if you are familiar with Faust, we will also learn easily Fausto. And also, like, we have all support for parallel, sequential, split, and merge composition. And the idea behind Fausto is not to replace Faust or to replace C major, but is thought and conceived like an entry point for people with little computer literacy or with little DSP programming experience to get familiar with how this work. And then there are many things that you can do with Fausto. Maybe there are some things that you will have to do with C major in terms also maybe of interface, but all goes together. Okay, so the concept of Fausto is a little bit the concept of modular programming. So we connect unit generators. These unit generators are come from the standard library of Faust. So Faust is a functional language. There is no object, there is no class. We implement this function like the oscillator, the rebus, the filter as classes, using also like inheritance and trying to organize the code in different packages and superclasses. The idea of the organization of the unit generator comes a little bit from the Chuck programming language, that is a high-level programming language, object-oriented, very fun to use, with a very good sound. So we also borrow the Chuck operator to connect the unit generators together. So when you connect unit generators with the Chuck operator, it knows what to do. So if you connect an oscillator with an envelope, for example, it knows that you are multiplying the output of the oscillator for the envelope. While if you connect it to a filter, it's going to the input of the filter, okay? So we make this chain of unit generator, then we send the message as DSP. We also send a message stereo if we want to do a stereo DSP instead of a mono. And then the DSP is compiled. We can then initialize it to our audio backend, port audio, core audio, and then we start it and we hear the sound. This was this basic, okay? This oscillator with an envelope, a filter, a resonant filter, and a SAT reverb that is a JC, a version of the JC reverb. We connect them together, and then if we send that, we have a message display UI to see an UI in Pharo and to play with the sound. But then we have this method called create C major MIDI patch name, and this creates a folder inside the document folder. It creates first a C major patches folder if it doesn't exist, and then it creates a folder with the name of the synth and with 3 files. One is the actual C major file, one is the C major patch, and one is the poly wrapper that manages the polyphony of the synth. Also, if we don't want to create an instrument, but we want to create an effect, we send the message create C major effects patch name instead of MIDI. This was, you can see the different, like the code in Phausto and the code in Faust. The code in Faust is kind of much more verbose because in Faust you have to define UI parameter if you want to control in real time the parameters of your DSP, and also if you want to see the UI. While in Phausto, everything comes already with a UI defined. So the only thing you have to do is to define a gate parameter, a FRAC parameter, and a gain parameter to have a MIDI synthesizer. This is just the beginning of the C major code. Of course, this is not the C major code that you will write for the same synthesizer, but it is like the exported version from Faust, so it's much more verbose. Then once you have the C major patch, you open the C major plugin, you drag and drop the C major patch file, and you have a synthesizer or effect with a generic UI. You can write your UI in JavaScript. I think there was also here, there was some talk about making the UI in C major with JavaScript. And that's almost everything for the slides. Now we will try to see some code together live. and just talking about what we have next. So now we have like ported 65% of the huge library of Faust. We want to port everything you got in Faust. We want also to implement some kind of auto smoothing, because now the parameters are not smoothed, so it can sometimes give to some kind of cracklings. Also, we are going to implement more toolkit object. This toolkit is conceived to be some kind of higher level unit generators built on the top of what is offered by Faust, like to select files, to handle envelope, or to make filter envelopes, or like effects with dry wet control. So to make easier, the idea is the user of Phausto can have a good library of high-level object to compose their DSP. But of course, they also can write low-level stuff just with mathematical operators. Of course, this comes with a question: why should I re-implement the wheel? Why should I implement the CZ oscillator if the people of Faust did it so well? Well, there's a question. And then here you can see we have two examples of the UI made in Pharo with Block, that is a UI infrastructure, low level, very nice and very powerful. On the left, we have the standard UI that it comes just sending the message display UI to a DSP. And on the right, you have a very nice TB free of free clone made by an intern, Janesh. It looks really nice. And the idea is to have some kind of exporting this UI to a JavaScript file, so we can have a custom UI for every C major patch we have created. Also, we have to work on more video tutorials and a booklet on Phausto, like a guide. There is a short workshop I did at the Faust conference online. I will put the link. And then as soft computing, we want to make available the C major wrapper on our Bandcamp page, and then start developing a series of low-cost scenes and effects, or also something for free, just to encourage sound artists and musicians to use C major patches, because we really think that this probably is the future of the developing instrument and effects, at least especially for not people that are not like developers for their job. And that's all for the introduction. Let's say that's all for the slides. Now you can see Pharo. This is the Pharo environment. We have the playground. We can open different playground. We can evaluate our code. Okay. So for example, here we can have, I made this example. We have two oscillators, one for the left channel, one for the right channel. We don't need the stereo here. And then every unit generator has a set of setter, and this setter, depending of the argument of the method, if it is a symbol, it changes the label on the UI. If it is a number, it changes the initial value. If it is another unit generator, it assigns this unit generator to that parameter. Okay, and that, for example, we can go. What happened? We can go to the class and opening a class browser with command P and go here and see the comment, what it is. It is attack release exponential envelope generator, and we can see that it has a sustained value, okay? The initial value, the minimum value, and it is a subclass of envelope, and envelope also has attack and release and a trigger to trigger the envelope, of course. So we can evaluate this. We can command D, evaluate this, then connect the left oscillator to the left envelope, connect the right with the right one, and then use the parallel we keep the parallel combination with comma, as in Faust, make a DSP, we initialize, we start, we display the UI comes. Now I have to change a little bit my inputs to hear the sound. Let's we can test the patch with the UI, we can play it, we can connect a MIDI keyboard and use the MIDI keyboard to play it or to control the parameters. And then we create this MIDI patch we create the C major patch. In this case, it's a MIDI patch. And it will be on our document folder. It's here, it tells you, and we have all the file. And then, for example, in Ableton Live, we can have like the C major plugin that's using Ableton Live because everybody knows it. Okay, and then we can take the C major patch. Okay, now we have an error. For example, we didn't find the gain. We always have to define gate, frequency, and gain to gate, FEC, and gain. So here, for example, I can say like that we want a gain. Okay, so in Pharo we are cascading message. So here, for example, we create an envelope, we create the other envelope. Then we want to create this new square oscillator with this label for the frequency, but we want also to change its level. All the unit generators, all the oscillators comes with a level control in Phausto by default. So we can just call this level control that is called U level. We give it the label gain. And this is semicolon is called the cascade operator. So we have like cascading messages. We are sending FREC and then U level to there are two keywords messages. We can do the same for the other oscillator. So let's evaluate again. I'm missing a bracket. Okay. Okay. Evaluate again. Let's see if it works now. Okay. And you see the patch is generated, and there is this kind of hot reloading of the C major plugin that is super cool. So when you change the Phausto code and you export the code, it's reloading if you change something. And now we can just play some MIDI notes. Just see it goes. It's clear. Okay, so it's all by my side. We got a very quick demo, but there are more things to see, and I'm open to questions.
Great. Is there anything else you'd like to say?
Not so many things. I mean, a lot of things, but I think to do a tutorial on Fausto, we need a little bit more time. Now it was a lot of information, but it was to give you an idea of what you can do and the motivation behind that. Also, yeah, maybe just a little thing, just another short thing. You know, even if you have like developed a plugin in C++ or Juice or whatever, and you know how to do it, then it's like half of the work, because if you want to share the plugin with somebody else, you have like to code sign, notarize. You have to do it for Windows and for Mac and for Linux, and like, so if you have a very like an instrument you want to share it with the world, share a C major patch is much easier.
Hmm.
This is one very good point about C major.
Yeah. Yeah, absolutely. That's fantastic. Stefan Letz from the Faust team was in the chat a little bit earlier. Hopefully he's still hanging out. Um, looks really interesting. So what are the future plans for this?
Yeah, the future plans for, as I was saying, the future plans is to have everything of the Faust library, to have a way also to export the UI made with Pharo, because it's a lot easier to made, at least for me, but uh, to make a UI with Pharo than to make it with JavaScript. Uh, but it will be an option, and of course to encourage people to use C major, and so to use Fausto, and it goes all together. Then also, like, there are other stuff like, if you want to play sound files, maybe you have to work a little bit your C major code. So maybe we should do some tutorial of step by step, making something in Fausto, then tuning the code in C major, and stuff like that.
Yeah,
So the idea is to spread it more to the world.
that's awesome. Um, looks like we don't have any questions from the chat, so we'll go ahead and wrap this one up. Thank you so much,
Okay.
Domenico.
Thank you. Thank you very much.